We've learned about how to evaluate them, solve them, in some cases even write equations, but now we're going to talk about writing functions. So let's talk about a couple of things. First of all, we recognize that a function is some type of an equation that equates an output with an input. And for each input that we put in, we get one distinct output out of it. Now, you will recall that we've been talking about how y equals mx plus b is, which we call the linear equation, slope-intercept form, is also a way of writing an equation in function form, where it is solved for one variable and everything, that variable is dependent on what we put in on the other side for the other variable. You also remember that we've talked about different kinds of vocabulary that represents addition, subtraction, division, and multiplication. And these words will be used again on this assignment. So when we see words that represent addition, we'll remember to put plus signs in for our function rules. And when we see different words like difference or decreased by, we'll know to put in subtraction signs and so on. So let's get right into it. Let's practice a few of these and see how this is going to work. So let's start with this one. We're going to write a function rule for the output is 5 less than the input. So I'm going to grab my little pen here. So remember, to write a function, we usually do f of x, or we could have written y there, equals, and then the output is 5 less than the input. So if this is the input, then we have to decrease it or take away 5 from it to get the output, which was what we'll see on this side. So f of x equals x minus 5. That would be our first example. Let's try another one. Write a function rule for the output is the square of the input. Okay, so if this is the output, f of x or y, and it is the square of the input. So input is x. So to show that we're squaring that input, we just put a 2 on there, so the second power. So f of x equals x squared. Okay, let's keep trying a few more. Write a function rule for the output is 1/4 of the input. So the output, f of x, equals 1/4 of the input, and the input is x. Okay, how about this one? The output, f of x, is 8 more than the input. So that would just mean that we would have the input, and we would add 8 to that to be 8 more than the input. Okay, write a function for the rule. The output is 4 times the input. All right, so the output, f of x, equals 4 times the input. So in this case, we'll just have 4x, which means 4 times x. So as you can see, these are not very difficult to produce, and we've done some of this before, so it's not completely new to us. Okay, now we want to move on because there's other ways that functions can be represented, and one of those is a table of values. And so if we're given a table of values, we still need to write a function rule for it. So let's remind ourselves that the slope of a function is the change in y over the change in x. And so if we're given this table of values that represents a function, first of all, we need to find the slope and the y-intercept. So the slope is the change in y. So I'm going to look at a couple of values here, and if I notice if I go from the first y value to the second one, that I'm going from 5 down to 2, so I'm decreasing by 3. And then to go from, on the y direction, to go from -1 to 0, I'm actually coming up 1. So my slope then is going to be -3, change in y, over the change in x, -3 over 1. Now to find the y-intercept, all I have to do is go to my table of values again and find the 0 in the x column. Here's the 0. And if I look down and look at the y value is 2. So that means that the y-intercept is 2. So now when I write the equation or the function, I'm just going to write f of x equals negative 3x plus 2. And if you put that 1 under there, that's okay, but usually we don't show that. Okay, let's try another one. This time, let's go ahead and find the y-intercept first. Let's find the 0 in the x column, because we know that at the y-intercept, the x value is 0. So there's 0 in the x column. The y-intercept then is going to be that number 2 right there. And then we're going to find the slope. So to find the slope, we need to find the change in y over the change in x. So in this case, we got the y values on the bottom. So to go from 6 to 10, that's an increase of 4. Let's just look at another one just to double check that. So to go from 10 to 14, that's a change of 4. What about in the y direction? So if you look at the x direction, excuse me, if you look at the top one, to go from 1 to 2, that would be an increase of 1. And to go from 2 to 3, that would be an increase of 1. So the change in y over the change in x would be 4 over 1. So the equation then would be y equals 4x plus 2, or if we write it in function form, f of x equals 4x plus 2. So that's not too bad either, is it? Let's try 1 or 2 more of those. All right, so let's start with the slope this time. The change in y here, to go from 1 to 3, the change in y would be an increase of 2. And then in the x direction, to go from negative 5 to 0 in the same interval here. So if I started at negative 5 and went up to 0, that would be an increase of 5. Then I look and find the 0 in the x column, and I look down at the y value, and I notice that that's a 3. So the y-intercept is going to be 3. So then my slope then is the change in y, which is 5, over the change in x, which is 2, and the y-intercept is 3. So now when I write my function or equation, I just write down 5x equals 5 halves x plus 3. So f of x equals 5 halves x plus 3. All right, let's try another one. Okay, let's start out with our slope again. So in the y direction, to go from 2 to 0, that means I'm decreasing. I'm going down, so I drop by 2. But in the same time, in the x direction, I go from 0 to 2, which means I increase by 2. So my slope then is going to be negative 2 over 2, which simplifies to be negative 1. Now I'm going to find my y-intercept, so I look for the x or 0 in the x column, and then find the y value that goes with it. And the y value that goes with that x value of 0 is 2. So that's my intercept. So my function, when I write it out then, would be y equals negative 1x plus 2. Okay, what if I have an equation graphed on a coordinate system? So we've kind of talked about this before, but you notice that that line kind of comes up through there, has a slope, and has a y-intercept. So the y-intercept right there, the y-intercept, or b, is negative 3. What about the slope? Well, I just kind of look really close. Now I have to look at my numbering here. I notice that these, on this x-axis, I jump up by 2s. So this would be 1, 2, 3, 4, 5, 6. So this dot right here lines up with the number 3 on the x-axis. So that's kind of important. So I notice then as I go from 3 or negative 3, if at that point right there, if I go up and over, then my rise is 1 and my run is 3. So the slope would be 1 and the run would be 3, and the y-intercept is -3. So when I write my function, I'll have f of x equals 1/3 x minus 3. And that's how you'd write the equation for that line. Okay, let's try another one. This particular one has a y-intercept at -1, so let's just write that down. Now let's check out the slope. From the y-intercept or any of the other points to go up and over, I just need to go up 1, 2 steps here. So that would be up 2, and over 1. So there's my slope. And so my function would be f of x equals 2x minus 1. All right, I'm starting to get the hang of it. Okay, so here's a real life application. You're traveling on the highway at a rate of 55 miles per hour. Write a function that represents the distance traveled in h hours. So the distance is going to equal 55 times the number of hours that you are going 55 miles an hour. So if we write that in function form, that would look like this. D, which is dependent on the number of hours I'm driving, d of h equals 55h. How many miles do you drive in 6 hours then? Well, in that case, the distance after you drive for 6 hours would just be equal to 55 times 6. 6 times 5 is 25, so 5 carry the 2. 6 times 5 is 30. We got to go back and correct our mistake here. 6 times 5 is 30, not 25. So we've got a 0, carry the 3. 6 times 5 is 30. 30 plus 3 is 33. So in 6 hours, you will go 330 miles. So don't forget your units when you do problems like this. 330 miles. Okay, let's see here. We're getting close. We got one last example here. Okay, the cost of admission for a student is $4 less than the cost of admission for an adult. Write a function that rates the cost of the admissions for a student Y with the cost of the admission for an adult X. Okay, so it says up here that the cost of a student is $4 less than the cost of the admission for an adult. So that means that an adult, okay, for a student, so here's the cost for a student. And then that means that if I take the adult admission and subtract 4, I would have the the student admission. All right, so I could write this in function form. F of x equals x minus 4. So what is the cost of admission for a student when the cost of admission for an adult is $7.50? So the cost for a student when the adult cost is $7.50 would just be $7.50 minus 4, which equals $3.50. So that would be our answer for that one. All right, so there's the kind of problems you're going to see on today's assignment. And today's assignment is on a worksheet, and we'll hand that out during class, so you can print that out off of our Today button on our Canvas page, and good luck. Thank you very much.